Hi, this is Dr. John Bergduff. In this video, we're going to explore how to take a number written in a base other than 10 and find the equivalent value in base 10. Or in other words, how to convert a number from a different base to base 10. We're going to start with a number in base 3. And to help me relate to this, since I've created some base 3 blocks as manipulatives, I want to represent that number that we're looking to understand, and then we can talk about how to convert it. So 212 or 212 in base 3 would imply that you would have 2 flats, 1 long, and 2 units. So this is a representation of the number 212 in base 3. Let's write that in a chart where we emphasize the flats, longs, and units like this. So we have some flats, we have some longs, and we have some units. Now I'm actually going to leave a little bit of space and create another row in here. So just kind of bear with me. I'll show you what that's about in a minute. But basically in this example, we have 2 flats, 1 long, and 2 units. Let's see what that means exactly. So units are no problem. Units are worth 1 or just 1 solo square, meaning just 1 unit. I'm going to put a 1 right here for reasons that you will see in a minute, indicating that each one of these little squares is simply 1 unit. A long, however, consists of 3 units. So instead of saying units, I could say ones. And instead of longs, I could say threes. And then looking at the flats, they're 3 by 3 or 3 squareds, which is the same as 9. And so when I say I've got 2 flats, 1 long, and 2 units, I could also say I have 2 3 squareds or 2 groups of 9. You can see the 9 very plainly right there. 1 group of 3 and 2 single units. The reason I emphasize those values of the units, longs, and flats is it tells me that I'm going to be able to create essentially an expanded form for a base 3 number. Remember, we talked about that with base 10, how we looked at each place value as representing a power of 10. Well, in base 3, each place value represents a power of 3. So when I say I have 2 flats, I mean that I have 2 3 squareds. So I can say 2 times 3 squared. 1 long means I have 1 3, 1 times 3. And 2 units means I have simply 2 times 1. This would be the number 212 base 3 written out in expanded form, emphasizing how each place value is a power of 3. This is essentially 3 to the 0, 3 to the 1, 3 squared, and then there'd be a 3 cubed if need be, as you go from there. Now, why do we write that in expanded form? Because essentially, expanded form tells you the calculation that you will need to do to convert this to a base 10 number. This simply is an operation that we can take care of, and let's just do the math and see what we get. So 3 squared is 9. Let's just do that much first. That means that each flat consists of 9 units. We can see that plainly. 1 times 3, that means we have 1 long that has 3 units, and 2 units each worth only 1. Doing the math, this is 18, this is 3, and this is 2, and that adds up to 23, which is the base 10 number that is the equivalent of 212 base 3. You know how we can check that? We can simply count the squares in base 10 as we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. There are 23 squares altogether in the counting system we usually use, which is base 10. And the way to get there simply is to think of our number, think of it as if it could be created in base blocks, convert to expanded form, do the math. That's your base 10 number. Let's try a couple other examples just to make sure that makes sense. So one base that ends up being extremely important is base 2. Base 2 is basically the language of computers, where everything is simply strings of ones and zeros. So if we talk a little bit about bases, just a little bit, based on some things we've seen in previous videos, if we're talking about base 2, that means that every group is in powers of 2. Every place value is powers of 2. And the digits that you could use, remember the digits run from 0 up to 1 less than the base. So the only digits are 0 and 1. Let's write down imagining that we had base 2 blocks, a chart that it breaks this up into units, longs, flats, and then we have to go one farther and have cubes. So we'd have cubes, flats, longs, units. Again, skip a space because I'm going to interpret those as in terms of powers of 2. Our number simply has 1 cube, no flats, 1 long, and 1 unit, but everything is in groups of 2. So our units are simply units, they're ones, but our longs, instead of being 3 units, would only be 2 units. So these would be 2s. And our flats, instead of being 3 by 3, would be 2 by 2, or 2 squared. And our cubes would be 2 to the third. So 1s, 2s, 2 squareds, 2 to the third. So when we say we have 1 cube, that really means we have 1 2 to the third piece, one piece with 8 blocks in it. No 2 squareds, 1 2 and 1 1. Convert that to expanded form. And that would be this many 2 cubes. So 1 times 2 cubed. This many 2 squareds. This many 2s and that many 1s. And then we can just simply do the math. 2 cubed is 8, times 1 is still 8. 2 squared is 4, but times 0 would give me 0. 1 times 2 is 2, and 1 times 1 is 1. So just doing the math, we see that we'd have 8, 10, 11. And what that tells me is that 1011 in base 2 is equivalent to 11 in base 10. If we know we're routinely in base 10, we don't usually put the base symbol there, but since I'm going back and forth between different units, I want to emphasize that that's my base 10 equivalent. So again, imagine units, longs, flats, and cubes. Create a chart. Think about how the units, longs, flats, and cubes are powers of whatever your base is, and then use that chart to write expanded form and do the math, and you will come up with the base 10 number. Here's a weird one. Bases can be greater than 10. We're going to talk a little bit about base 12. And notice I've got this weird looking thing here, 39T. What the heck is that? Well, let's talk about what that means. So if I am in base 12, that means that every place value represents powers of 12. And the digits that I use need to be from 0 up to 1 less than the base. That starts out normally 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you'll be tempted to say, okay, well, then I need 10. But that's actually not good. because the 10 as a two-digit number implies one long and 0 units. So that's actually representing two place values. I can't use a two-digit number for a one-digit space. So if you have a base that goes bigger than base 10, what you do is you have to make up symbols for the numbers reaching up to one less than whatever your base is. And traditionally in base 12, we use the letters T and E, which, as you can guess, stand for 10 and 11. And I'll show you how that works in a minute. So let's imagine that we had base 12 pieces where my long had 12 units in it, and my flat would be 12 by 12. And let's write out what this would look like. So we have no cubes this time. We just have flats, longs, and units. Notice how this method works no matter what base you're converting from. Leave yourself a space because we're going to think about what those mean a little bit more carefully. And then write into your chart how many of each you have. You have 3 flats and you have 9 longs. And for the purposes of calculation, we can now recognize, oh, okay, the T represents 10. I'm going to put 10 because there are 10 units. Again, I don't want to write the 10 in the symbol because then, as you can see, the 3-digit number would turn into a 4-digit number, creating more place values. You have to have that special symbol. But when you do the calculations, you can remember, oh, T is 10, and if there's an E, that's 11. So my base is 12. Units would be ones. Longs would be 12s, so 12 units in a long, and 12 squared units in a flat. So we have ones, 12s, 12 squareds, and if we needed cubes, we'd have 12 cubed. Use that chart to create an expanded form. We would have 3 flats, or 3 times 12 squared, 9 longs, or 9 times 12, and 10 units, or 10 times 1. And this calculation will give me the base 10 equivalent. May need a calculator for this, so let me get one handy here and clear that out, and we'll do the calculation. So 12 squared, we punch that out, is 144. So 3 times 144. I'll do all these calculations in the next step. And see if there's not too much glare there. You can see the 12 squared is 144. Then 3 times 144 is 432. 9 times 12, 9 times 12 gives me 108. 432 plus 108 plus 10. And I simply add those 3 numbers together. 432 plus, try to get that out of the glare as much as possible. There we go. 108 plus 10. And the answer is 550, 550. That would be your base 10 equivalent. So 39T, which we really couldn't read any better than that, 39T in base 12 is the same as 550 in base 10. And you do the same thing no matter what the base is. If you're in base 5, then these are powers of 5. 1, 5, 5 squared. If you're in base 7, then these are base powers of 7. 1, 7, 7 squared. Base 16 is used also in computer science. 1s, 16s, and 16 squareds. And for base 16, you need more units. So although you don't see this as much anymore, it was very common in the early days of computer science that you'd need to look at base 16. And you would have the units 1 through 10, no problem there. Or 1 through 9, sorry. And then you would need values to represent everything up to 1 less than 16. That would be 15. And what was traditionally done is they would use A, B, A for 10, B for 11, C for 12, D for 13, and E for 14. All right, I hope that gets you started on the process of converting other bases to base 10.